Let's build a circular polarized damn dull antenna.
It's a CNI antler, just so you know.
CNI antler. So, RG316 with SMA connectors on either end. We'll have to adapt it for RP SMA, but what are you going to do? 4060 rosin core solders. This is 023 MIG wire. We've already cut them. I'll put a link in the description. But you go to rcexplorer.se and put in what bands you want to run it on. Say, 5.8, but we're actually running these on 5645, which is like channel 4, I believe. So it spits out what you actually need to cut them to, and then what you need to bend them. I'm going to need the computer because I need to make those bends.
And we need to check the size, make sure they're exact. Right?
Good call, yeah.
You got your calibrators?
Do you got the internets in your car?
I didn't bring the internet with me. Sorry.
So my partner's a bitch. He never does anything.
Well, I don't have the vagina with me.
Okay, so we'll have to use my phone. Alright, so anyway, need calipers, 120 degree template because we're making a clover leaf, and we'll need some bending eye antlers, and I think that's it. So
I want to show you rcexplorer.se. Let's open up Google Chrome, and then we're going to type in a web browser, rcexplorer.se, and then I'll put this link in the description. This is a website that has quite a few guides and projects and educational information. It's a really handy little site. There's quite a few things. So let's click on DIY. And then we're going to click on DIY circular polarized antennas. And let's click on the cloverleaf antenna since that's what we're building. And this is a written guide, and it's a very good written guide on how to build a cloverleaf antenna. We're going to scroll down though, and you're going to see a box that we can enter in some values, and we're going to enter in the frequency that we're currently using, which is 5645, and it's going to spit out a measurement for our overall length of our wire. And you can use any frequency you want, all the way from 900 megahertz to 5945, whatever it is. And then we're going to enter it in down here as well, and this will actually give our bend dimension, where we have to bend the wire at, and then we're going to subtract half the diameter from that value and make our bend. So let's go ahead and get back to the video. I just wanted to make sure that you could see this website and how handy it can be.
So RC Explorer says that for a 5645 we need to be about 54.38 millimeters, which we are, and then we need to make our bend at 1359, but we need to factor in half the thickness of this wire into the bend. We're going to subtract that from that number. So this is really crappy. What I need to do is find out how thick the wire is. Zero out the calipers. I hope you didn't close it. The wire is 0.59 millimeters, so 0.59 divided by 2. So we're going to subtract 0.295, so we'll subtract 0.3 from both sides of the bend. And we wanted to bend at 13.59, so let's do 13.6 minus 0.3, which is going to be 13.3. So I'm going to set my calipers to 13.3 millimeters. Alright, 13.29. When I close it, it's going to be 0.3. Alright, so 13.3. That's good enough. Not going to worry about this for a moment. What I'm going to do is I'm going to go ahead and bend these into the shape we want. We need 3 of them. And I need to straighten them out a little bit, or as best as possible. Get a fairly straight wire. And then all we do is we butt the wire up to the caliper end, and then I put my pliers up to the other end, like so. And that gives me the exact spot to bend. Then all I do is take and put a 90 degree angle on it with my pliers. And I do both sides. Just butt it up to the calipers, put my pliers on it,
cheat it over.
Yeah, cheat it over. 90-degree angle.
And then do you measure it again to make sure it came out right? Or?
I do not.
Really?
Then I make sure that these are both parallel and vertical, and they are, and then I'm going to set it down, and I'm going to do another one. I'll go ahead and bend 3 of these up, and then we have to actually put a 110-degree angle in it. Alright, so there's my 3 lobes. This is a clover leaf. 3 lobes. It has overall higher decibel gain. The skew planar has better multipath rejection, so it makes a better receiver antenna. Now we're done with this. Now we come to the RG316. We need to figure out how long we actually want the wire. We need to be a minimum of 6 centimeters, I believe, to get out of the Frenzel zone that the antenna creates. So I'm going to go ahead and set this to 6 centimeters, which you can tell, I mean, it's not very big. There's 6 centimeters. It's about 2 1/4, or not 2 1/4, but almost 2.5 inches, 2 3/8. So we're going to go 7 centimeters, and we'll just cut her off, and then I'll start stripping the coax. Bink. All right. We got to strip this coax, and underneath the top shield is a braided conductor, and we're actually going to flare that out, and we're going to twist it into this 120-degree pattern. We're going to flare it out, and we're going to separate 3 lobes, twist it out, and that's what we're going to actually solder the wire when I get these done bent. When I get these bent, we're going to solder the wire to that. It's called bottom feeding, I believe. And then you actually score that center insulator, and there is the center conductor, and that also attaches to the other side of the lobe. So how I do this is I go about 1/4 down from where I'm cut, and I barely roll the coax on a sharp razor blade just to score it. I bend it a little to make sure I broke through without breaking the wire. I might have to get a tool on it because my thumb's not wanting to pull it. There we go. I know you can't see this very well, but this is where I scored it. This is the metal. It's a shielding. It's braided. I don't know what it is. Aluminum, silver. And then we're just going to pull our finger on it, and we'll start flaring it out. And we want to spin it as we do because we want to get kind of like equal parts distributed around the entire thing, and we're going to bring it all the way down flat. And we still have a center conductor that's still got the sheeting on, and we're going to leave that for a moment. What I need to do now is actually take this braiding and make this 120-degree angle. So I'm going to grab a pinch of wire on any side, and I'm just going to twist it into a solid piece. And that's going to be my initial lobe. Take any excess, and then I want to take some more other places and try to get my 120 started. Now, when I first started building these, I was real careful about my angles, and everything worked fine, but as I built more, I realized that with 5.8, close is good enough because there's so many errors that get introduced. There's no way to make it perfect. It's just so picky on measurements that, I mean, do your best, right, if you're trying to go for records, but honestly, if you're going for records, you need to just buy them pre-made from like I'd Be Crazy or his are the Blue Beams or True RC. I think Hugo makes those. He does does a little bit different kind, but supposedly they're really good. But anyway, I'm just trying to make 120-degree angles, and then I eye it up, make sure it's pretty good. It is. Bend them just a little bit. I can live with that. So once I get my 120-degree angle, used to I'd actually build a jig. I know this is probably not what you guys want to hear, but I'd build a jig and I'd set it in there and I'd put 45-degree blocks on it and I'd get it all taped down. But to be honest, it's just as easy to hold the lobe on and just solder it. Yeah. So I'm done with the pattern. I'm going to go ahead and tin these wires that I pulled out for the bottom feed, and I tin them because it makes them strong, and then I can go ahead and cut that center conductor without worrying about distorting my wires. When I'm working with these, RG316 is tolerant to heat, but I mean you still don't want to heat it up, so I use a thin tip, a pencil tip, and I set my iron to about 600 degrees Fahrenheit, which I know is still hot, but I've been doing this not a lot. I'm not a professional, but I know when I'm gonna like tear it up, so I know when to stop or if I'm putting too much heat on it. The idea is to touch it quickly and just wick that solder on and get it all the way up to the base, because that will actually help hold the tanna. Just let it wick, but don't melt that center conductor. That's a big no-no.
Don't cheat it before you do this because you need a lot of concentration.
Yeah, and you can go to jail.
Well,
that's another caveat of cheating it.
Well, I don't think they're going to come to your home and know when you're cheating it in your own home.
Well, I mean, I don't know.
Just don't advertise that shit.
We don't cheat it, just so everybody knows, especially any cops that are watching. Now we got to cut the center conductor, and this is going to kind of determine the feed gap. And basically what the feed gap is the difference from where the bottom of the lobe attaches to this arm that comes out to where the other side of the lobe attaches the center conductor. We want like less than 1 millimeter feed gap, which is really hard. I've gotten to where I cut almost all the center conductor off, and then that kind of gives me a guide as far as where to attach the top of the lobe and give me the smallest feed gap possible. So again, with a sharp blade, I just set it on there and then I spin the coax around, and I just want to score the insulator. There we go. That one. There we got her. Now I got a little more feed gap than I like, but when I put this on, it takes half of the feed gap away, which is still too much for my liking, so I'm going to cut a little more insulation off.
Yeah, I cheesed your way down last time. Just kept gnawing at it with my beaver teeth.
Sometimes you gotta gnaw at it with beaver teeth. If you don't have beaver teeth, you can get hit in the face with a caulk gun from a 25-story building.
Yep, you sure can.
And it will beaver teeth you up. Okay, that's going to be good for me. And I go ahead and tin the center conductor before I cut it. I don't know that you have to. This is how I do it though. So again, small amounts of heat. Well, large amounts of heat. Small time on the actual conductor.
That's all the further you go down with that, huh?
Yeah, because that assures that I don't get a short. That last one you did
too much
was almost shorted out. Like I
had.
Because
before when I did it, you told me I didn't go down enough.
Well, yeah. There's it's called a balance, right?
I didn't cheat it. Don't worry. It's okay.
Just saying that just because you didn't go down far enough one time doesn't mean that you have to go all the way to the bone the next. Then I go ahead and cut the conductor, and I only leave less than a millimeter, half millimeter maybe. I mean, if you can even measure that. I just do it by eye anymore, because all that does is get a glob of solder when we put the lobes on. And then I guess what I need to do now is go ahead and set this aside, and we'll go ahead and bend up the lobes, because these need to still be bent into 110-degree angles. They actually get a round curve to them. Some people seem to struggle with this, like the guy sitting next to me, but it's really easy. You just use a pair of pliers, or this is how I do it. You can even use a dowel rod and make a jig, but I'm all jigged out. I just start at the very end. I put it in my pliers. I give her a little crank, and then I move my pliers down. I give her a little crank, and then I move my pliers down. I give her a crank. I just keep moving my pliers down and cranking on it. And as I do that, it starts putting a circular bend in it. And I come back. I just keep doing this slowly until I feel like I got a good bend. And you already start seeing how it's giving us a football shape on the one side. And we're going to keep bending it like that until we can get all the way across, and these basically almost touch. And you can use your pliers to kind of help straighten out the lobes if they get a little wonky-donkey. Like this one's wanting to be kind of hateful a little bit. But just play with it. Just, don't take much. Just do a little bending, 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 little bending. And then this is kind of what you want right here. Again, you're not going to be able to see this, but you want a decent arc here, and then you want these to almost touch. There's about a 0.5 millimeter in between the two, and it's basically your feed gap. If I put this on a paper that was 110 degrees, it would be perfect because I'm that good, but I'm not going to do that because I don't think I have anything. So we need to do 2 more just like that, and I'll do that now. Also, people, if this footage actually makes it with the voice, the GoPro sucks for a flight camera. I just want to put that out there.
Yeah, that's the second one I bought. I tried the first one, the cheapie,
the Hero,
and
the Hero
we
2.
took it back. So I went and got the more expensive one because we figured, we'll just take it back, Best Buy. And I bought it, and the first day I bought it, I dropped it on the concrete and messed the lens up, so I had to take it back, get a new one.
That happens.
And then the second time around here, it's not really worth the money. May as well just get the $40 camera and call her a day.
I agree.
Okay, these are good.
Okay, so it's time to
good.
Okay, I hope you saw that. Because it doesn't have autofocus, so the closer you get to it, it just...
Well, I'm trying to work with a piece of shit
like,
camera, so...
It looks like puke. Helping hands. And I'm going to tin the bases where they actually connect. Oh, that helping hand is kind of got Down syndrome, maybe.
Yeah. Damn, you burnt it all up too, huh?
Well, that's back when I was building roll cages out of brake tubing.
Oh man.
I got another one. Here.
Yeah.
I want to load it. I bought a whole.
No, that's okay.
Okay, well, then shut your mouth. So.
You need the fan off, or you big enough to block it? Okay.
Fat boy. Get a good bit of solder on here. Make sure it connects or gets on, whatever you want to call it. I can't even tell if it did. It looks good. You gotta get real warm. And make it shiny. Alright, so now what I'm going to do here is basically hold it in one hand with pliers, and this would be handy if you have pliers that like self-grip. And I'm going to have...
Now this is the not fun part.
This is not fun part. I'm going to have John get this 45-degree angle up here that I got, and he's going to give me like a go, no-go signal. I need to rebend. I'm gonna bend this up so it's just a little bit easier to work with. And I don't know what he's doing right now, folks.
Moving it so you can kind of see.
Well, it's got to be over here.
You're gonna go that way. You want to see kind of ideally.
Yeah, but it has to be like this, bro.
Well, you need to tell me where you want it. That's all.
I just need you to tell me. Is it about 45?
Okay, get out of the way.
No.
All right, go ahead, solder it up. It's good to have a buddy that you can boss around to help you at this point.
Much better. I can live with that. And I got a little hunk of solder on here I'm going to knock down. If it'll let me. Okay. I can live with that one.
Show the folks at home.
Now I'm not soldering the top where the center conductor comes in yet. I'm going to go ahead and place all 3 lobes. And this is the very hardest part. Maybe a jig would be easier for some folks, but to be honest with you, this is not that bad. It's just, you got to get a little rhythm going. I'm going to So that's the 3 lobes. They're attached on the bottom. Now what I'll do is I'll bend all the bottom lobes flat because I want a flat plane. I think for this one the hardest part is actually going to be putting these sides on, but since they're all on, I can now go ahead and tweak these centers to where they want to kind of touch this center conductor. Like so. Like so. Oh, that one might be a little high. Let's bend her down a little. So all I did was bent all the lobes in a little to want to touch that center conductor. And that means that I'll be able to just stick a piece of, or just melt a piece of solder right in that center and it'll capture them all. In theory. Okay. I think I can work with that. Now what I'm going to do, and you do have to be kind of delicate, but we're going to drop the iron on the very top and we're going to melt a glob of solder in there. So we got to find a position to come in, heat it up a little, get it to accept some solder, and then you drop that glob on. Make sure it captures all 3 and the center conductor. And that's it. Again, you're not going to set world records with these, but for whatever this was, 10 minutes of time, going to be perfect video for up to probably at least a mile, 2 miles.